California has a huge water problem. For decades, they have sourced water from underground aquifers, but overconsumption of the otherwise desert region has caused the state to sink an unprecedented amount. Just last year, some regions sank more than 18 inches. Solving California's increasing water shortage is the biggest problem facing the area. Ever since regions in California became heavily populated in the early 1920s, engineers have been tapping into the local aquifers for water. This isn't normally a problem in states that get more rain, but for the otherwise dry areas in California, these aquifers simply aren't getting replenished. Between 1920 and 2013, Californians have depleted 41 trillion gallons of water from underground aquifers. That's enough drinking water to supply every person on Earth with a daily supply for 30 years. This draining of underground aquifers is the reason the state is sinking, in an area that is already seismically active. Imagine removing the equivalent volume of 150,000 Empire State Buildings underneath the surface. That's an unimaginable amount of mass and volume, but it is all forever gone underneath the state of California. When examining this problem, you also have to understand the effect it has on subsurface fluid dynamics. When you have such a high number of wells sucking water from these aquifers at high flow rates, you create an effect seen on every well, called drawdown. This essentially is a conical void formed around a well that forms when water cannot refill the space from pumping. In a healthy pumping situation, when the well stops pumping, the water level returns to the pre-pumping subsurface level and the aquifer stays comparatively full. In California, however, due to the nature of the environment, water isn't replenishing these voids and the porous soil is collapsing in on itself. The aquifer is literally shrinking due to the geostatic pressure of the soil above. There's another problem too. If we assumed that the aquifers are staying the same size, which they aren't, it would still take 50 years to replenish them naturally if the entire state of California stopped using water. Essentially, these aquifers will never be replenished. These problems present an interesting aspect of geological simulation that is not well understood. Currently, there is no governing agency monitoring the depletion of the groundwater in the area, both because no one really understands how much water is below California, as well as due to the financial problems the state faces. Engineers can run simulations all day long on the effects a well can have on the local groundwater. However, simulating all of the wells combined on a groundwater system of an undefined volume is another question entirely. In all practical senses, it's nearly impossible to simulate given what is known about the area. Without geological and hydrologic simulation in the area, engineers are essentially blind to the perhaps looming drainage of underground reservoirs. This makes engineering for the problem and engineering to solve the problem exactly like a game of darts in a dark room. Engineers may know everything needed to throw the dart, but finding the target is equivocally impossible.